So we're going to use the min and max property, I think that was property number 6 from the list of properties, to show that the integral from 5 to 7 of sine of 1 over x dx is between -2 and 2. Um, to those of you who've actually seen some integration problems, you know that evaluating an integral of sine of 1 over x would be very difficult. So we're not going to purport to actually find the value of this integral. What we are going to do is be able to at least say that it lies between -2 and 2. So using recall that the min-max property says that b minus a of times min of f, in other words, the minimum value that f achieves, is going to be less than or equal to 5 to 7 of f of x dx, which is less than or equal to b minus a times the max of f. So what we need to know is what is acknowledging that this is f, we need to know what its minimum and maximum value are. Now you may recognize that when we were doing the squeeze theorem or the sandwich theorem, I think our book calls it the sandwich theorem. I always called it the two cops and a drunk theorem, which is what they call it in Europe. We often use the function sine 1 over x because sine 1 over x is an example of a function that's very difficult to work with, but where we know certain things about its upper and lower bounds. Specifically, the sine function, the sine of anything, is always between 1 and -1. So what I can say is that -1, a different color for that, -1 is less than or equal to sine of 1 over x is less than or equal to 1. So I can say that the minimum value of sine of 1 over x is equal to -1, and the maximum value of sine of 1 over x is equal to 1. Technically, I haven't actually evaluated what the sine, what sine of 1 over x is on the interval 5, 7, but I know that whatever it is, it can't go lower than -1, and it can't go higher than 1. So that'll be enough to be able to prove this statement, as you'll see in a minute. We can see that in this problem, a is equal to 5 and b is equal to 7, using the language of, sorry, this should have been written as a and b like that. I hadn't yet put in what 5 and 7 are, but this is the abstract statement of the min-max property, and I'm now simply inserting the values 5 and 7 because of the statement I'm being asked to prove. So a is 5, b is 7, and we can just fill in what we know from the min-max property. That's going to be 7 minus 5 times the min of sine 1 over x is less than or equal to the integral from 5 to 7 of sine 1 over x dx, which is less than or equal to 7 minus 5 times the max of sine of 1 over x. So that gives us 2 times -1 is less than or equal to integral from 5 to 7 of sine of 1 over x dx, which is less than or equal to 2 times 1. So having just replaced these expressions for min and max with their actual values, which was this is -1 and this is +1, I get the statement that I'm trying to prove. I'm just going to, in line, I'm going to replace this with its product, so that comes -2, and this becomes 2, and that's exactly the statement that I was being asked to prove.